lesson. All right, ladies and gents. So before we get started with lesson 3, the median in the middle, okay, we're going to go ahead and we're going to download our personality colors campaign data. The reason why we're doing this is because for 2.3C, we have understanding personality colors, okay? This is going to be done at the end of class, and you need your data uploaded into our studio so that you can actually complete the 2.3C activity. So a quick synopsis, okay, we're gonna go to our ids.lbschools.net website and we're gonna log in. We will click on campaigns, and from campaigns, we will export the responses for the personality colors campaign as a CSV file, okay, as a CSV file. And then once we've downloaded and exported that, we're gonna then open our studio. Okay, we're gonna then open our studio. We're going to upload that CSV file into our files on our studio, and then we will import that data into our environment pane, okay? So we're gonna do that together. You're gonna watch me do it. If you know how to do it, you can just do it on your own here, and no one is going to be mad at you for that. So first we're gonna go to ids.lbschools.net. Notice I did not search for IDS, okay? I did not Google search it. I did not click on a random link. We wanna make sure we're on the ids.lbschools.net. Okay, so first I'm gonna log in here because that's what I need to do to access. We're gonna click on campaigns. Okay, so from campaigns, we're gonna find the one that says personality color, IDS period 1, Carpe in 2021 spring. There should be 93 responses here. Okay, and I'm going to click on the arrow, the drop-down arrow, and I'm gonna click on export data, okay? I will export my data to my desktop. Okay, I have my desktop right here, oops. Here's my desktop. I'm going to export it, making sure that it's saving as a CSV file here. That's what we need. Save that, okay? So now that I've downloaded that and it's saved it to somewhere where I know where it is. I know I put it on my desktop. Okay, then I'm gonna go back to my IDS homepage and I'm gonna go to our studio here. And I'm gonna log into our studio. Okay. Once I log into our studio, I'm gonna go into my files pane. Okay, I've done this a few times already, so you're gonna see it here, okay? But here we go, we're gonna upload. So in my files pane, right here, I clicked on upload, and then I'm gonna choose file. And the file I'm gonna choose is I'm going to choose the one that I just downloaded from my desktop. So I'm gonna make sure that my I'm gonna make sure I know where my file is. I'm gonna make sure I click on the correct file and open that up. And then I'm gonna click on OK. Okay. That's not good, Destiny. Okay. So now that I've downloaded, you guys can see this right here, March 2nd, 11:02. I've uploaded, I'm sorry, my file. I've uploaded it. Next step, there's 2 ways to do this. Some of you guys figured out that if you click on the data set right here, if you click on the file, you can actually import the data set directly from there. The other way is you click on import data set from CSV, okay? So you can do that. If you click on the data set and hit import, the same thing is gonna pop up and it's automatically CSV. The file is already chosen for you, okay? Good question, Sarai. So Sarai asked, how do I get the file and the environment pane? Sarai, give me 1 quick second, hon, and then I'll explain that to you. So guys, over here, once you've imported the data set, you want to make sure you change the name to something that's simple. So I can do colors 4 for period 4. You know, that's my trial here. So colors 4. And then I want to make sure, notice it didn't update here. Notice it didn't update here. So I want to make sure I click out of that and let it update here and have the shorter name that I put in there. And then I'm going to import that data set, and it should load here, and it should load here in my environment pane. So Saraihan, to answer your question, to get all of the all 4 panes, all you have to do is click on these 4 panes here and click on show all panes. Okay, you could also go under, I believe, view, and there's a way, panes here, show all panes. So there's a few ways of doing it, but the fastest way is you click on the little window icon here and click on show all 4 panes. Okay. All right, so if you see your personality colors data, however you named it, if you see it here in your environment pane, that means you are ready to use it, and you can use it when you complete the 2.3C data or activity, sorry. Destiny, yes, just give me, I'll do it, Destiny, I'll do it today during class, okay? But just so watch the chat. I'm gonna ask you for your information, okay? So just hang tight. I promise I'll take care of it today. All right, okay. So we've downloaded our data. Now we want to go back to our PowerPoint and get started with our lesson, okay? So can I make sure, I want everyone back with me, please? So can everyone give me a raised hand to let me know you're back with me on the PowerPoint side? And you can see our shared screen of the PowerPoint there. Okay. Thank you, Alex. Thank you, Sarai, Natalie, Munoz. Thank you, Jade, Katie, and Kenya. Thank you, Maddie, Jeremiah, and Evelyn. Thank you, David, Vicky, and Samayi. Thank you, Ishmael, Destiny, and William. Thank you, Alexis, Maya, and Stephanie. Okay. Thank you, Natalie Neves, Chris, and Trinity. Thank you, Tyrese, Dallas, and Dario. Wait, yeah, no, not Dario. Yeah, Dario. And thank you, Gabby. Thank you, Janelle. Okay, George, Matthew, Alexander, and Val. Let me know that you guys are here. Thank you, Alexander. Okay. George, Matthew, and Val, give me some sign that you're with me here. Okay. All right, ladies and gents. So let us get started with lesson 3. Okay. Now here is a disclaimer. Here is a disclaimer. Okay. There are a lot of journal entries. Okay, there's a lot of journal entries in lesson 3 that I have modified into either a discussion or notes instead. So whatever I have modified into a discussion or into notes instead, I want you guys to delete those questions out of your journal, okay? I want you to delete those questions out of your journal. So we're gonna be modifying our journal a little bit today. There's just way too many journal entries. So on that note here, okay, our objective for the day, ladies and gentlemen, for our lesson 3, median in the middle, you will learn that the median is another way to measure the center or typicalness of a distribution, and will understand how medians compare and contrast with the mean, okay? So we're gonna understand median as another measure of center, right? Or the typicalness of a data. And we're gonna understand how medians differ from the mean, especially when is it better to use median as a measure of center versus the mean. Now, some of you guys that had FST with me last year, this is review for you. Okay, some of you guys that had Algebra 2 with me last year, this is new to you. So I want you guys to make sure you're understanding the concept here. And then some of you guys that are my juniors, you know, this is also new to you. So again, same thing. Make sure you're understanding the concepts here. Our essential concept, the main takeaway for today's lesson, okay, is that another measure of center is the median, which can also be used to represent that typical value of a distribution. The median is preferred. Okay, now pay attention to this because it's telling you exactly when it's better to use a median instead of a mean. Okay, the median is preferred for skewed distributions. Remember left skewed and right skewed distributions? Okay, so the median is preferred for skewed distributions or for when there are outliers, okay, numbers that don't really fit the pattern of the rest of the data, or when there are outliers because it better matches what we think of as typical, okay? So we're gonna start off with some definitions here. And the first thing you wanna talk about is what is a median? How do we find the median? What exactly is it, okay? So during our previous lesson, we learned about the mean as the balancing point of a distribution and as a measure of center. In statistics, there are a few values that can be considered as measures of center. The mean is one, okay? Another is the median. The median is the middle value in a group of ordered observations. It is the middle value, right smack dab in the middle of a group of ordered observations, okay? So it's important for the mean, it doesn't matter what order our data is in. For the median, it is important that we order our data from least to greatest, okay? From smallest to largest values. That is important. I'll give you guys a minute to write this down. All right. So let's take a look at an example. Yep. So we have calculating the median. If you're using your practice book, this example is in the practice book as well. Okay, so we have consider the following numbers below: 8, 2, 6, 3, 7, 4, 9, 5, 5. Okay, it's important to know how many data points you have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers here. Okay, so since there are 9 numbers in the list above, we should be using the 5th number as the median. Okay, why the 5th? This is because it is directly in the middle. So there are 4 numbers. There are 4 numbers above it, and there are 4 numbers below it. Okay, so that's smack dab in the middle. But this, okay, is not the order in which we need our numbers in. we cannot simply pick the middle number of the list as it currently is, okay? Which would give us a 7, a median value of 7, right? Here, our middle number in this list is 7. But instead, you must first arrange the numbers in order from lowest to highest. So what we do is we rewrite our numbers and we rewrite them from lowest to highest. So 2, 3, 4, 5, and 5, 6, 7, 8, and 9. Okay. And then we go ahead and we find the middle number here. Now, one way to look at this, okay, one way to look at this is you can look at, okay, well, if there's 9, then 4 there and 4 there, that's going to be left in the middle. You can also, if you have a short enough list, you can just cross off from each end. So you can cross off 1, 1, 2, 2, 3, 3, 4, 4, and you're left with that number right there in the middle. So we can identify that our true median in this case is a 5. So our median value is a 5 here, okay? Now, you guys ready for some Miss K shortcuts? Okay, so whatever your number is, however many numbers that you have, you can easily figure out which one of your data points is like the center placement, right? So even though like we're using the 5th number and our median is 5, that doesn't always happen, right? Over here, we're talking about the 5th number in the order. So the 5th placed number in the order. So how can we easily figure that out? If I took my number of data that I have, which was 9, and I divided it by 2, so I'm cutting it in half. I want to know what is the halfway point of my data. What is the halfway point? Okay. This gives me a 4.5. Okay. So a decimal like this means that I have an actual true median. I actually have a true median. And that means that there's going to be 4 numbers above it, 4 numbers below it. There's going to be 1 in the middle, and that 1 in the middle is going to be my median. Okay. So this 4.5 is going to round to 5, which is going to be the 5th place for my median. Okay. Now, why did I explain it like that? Why did I explain it like that? Because sometimes what ends up happening is we don't get a nice 4.5. We don't get a decimal there. Okay. Sometimes what ends up happening is we don't get that decimal. Okay, so you're not always rounding. You're looking at like the next place. Yes, yeah, Sarai. You're looking at the next place, but that's if your n, right? That's if your n is odd. You're gonna get this decimal, which tells you, hey, look at the next place over, right? You're not gonna look halfway. So here's the issue that happens sometimes. Sometimes the number of values that we have is not odd. Sometimes it's even. So suppose I had another number, right? Let's suppose I had like an 11 here, right? Suppose I had another number, 11. You guys follow? Just giving you guys another example here. Suppose I had another number 11 there, and that would make this guy 11 here. Okay, so if I now have 10 numbers, right? I now have 10 numbers, and I cut it in half to see what's the halfway point. In this case, I get a whole 5. So 5 is the halfway point. But what does that mean? That means that I have 5 numbers above, and I have 5 numbers below. 5 plus 5 is already 10. So that means I have nothing left in the middle. Okay, visually, what does that look like? Watch. If I do my cross out method here, watch what happens. Cross, cross. So that's 1, 1, 2, 2, 3, 3, 4, 4. If I were to cross out 5 and 5, I would have nothing left in the middle. So how do I find my median here when I have two numbers left in the middle? Okay, well, I take their average. So I do 5 plus 6, and then I divide it by 2. So I'm taking their average, which would give me 5.5. So my median value for this would be the average of the two middle ones. Okay. So when you have an odd number of values and you get a decimal when you divide by 2, that decimal, that whole number, that's the how many values you have before it, how many values you have after it, and then those 0.5s add to give you that one that's left in the middle. But when you have an even number of values, you're going to get that whole number. That's going to be 5 above, 5 below. You're not going to have anything left in the middle. So you're going to end up having to do this. You're going to end up having to average your two values. Okay. So an easy way to find that middle placement, that middle number. Okay. Remember, it's not the value. You're not finding the value of your median here. You're finding the placement of your median. Which number, which place in your data is your median going to be? That's what you're doing here, right? So when your n is odd, okay, you're gonna be easily be able to find your median. When your n is even, you'll probably have to average the two middle. Okay, so when your numbers are odd, you're easily going to be able to find. You just round that decimal to the next number. Round to next whole. And when your quantity is even, you'll most likely be averaging the two middle numbers there. Okay. Just a bit of extra notes there on how to find your median. This comes in handy. I'm not gonna lie, this comes in handy when you have larger sets of data. Okay, this comes really in handy when you have larger sets of data. When you have small sets of data like this, you can just do the cross out method. But when you have larger sets of data, it's easier to just be able to figure out, okay, what placement is my median going to be in? Let me go find that. Okay. Okay, anyone have any questions on this? Okay, I hope that was clear enough for you guys to understand. So if it's not, please make sure that you ask questions. I want to make sure that you're not getting confused here, okay? Okay, so let's take a look at, this is a discussion. So this is the first thing that I've changed on your IDS journal. These two questions are questions that are in your journal currently, but I want you to delete them. Okay, what is the problem? How could you create the median here? So if you go to your Unit 2, Section 1 journal, Lesson 3, these should be the first two questions. I don't want you answering them in your journal. You don't have to, so you can delete these questions out of your journal, okay? But we're going to talk about them. It says, consider this scenario. A class of 28 students was randomly given sticky notes with the number 0 written on all of them but one, which had the number 1 million on it. Okay. So a class of 28 students was randomly given sticky notes with the number 0 written on all of them but one, which had the number 1 million on it. What is the problem? How could you create the median here? Okay. So what's the problem here? Right? The problem is we have 28 students. 27 of them have a 0 on their sticky note, and one has 1 million written on their sticky note. Okay, yes, thank you, Sarai. Okay, write publicly, hon. You're on it. That's a huge outlier. This is what we would call an outlier, guys. Right? You have all these values of 0, and then you have an outlier that's like a million. 0 to a million is huge, and there's nothing in the middle, right? So how would I create the median here? What's a good way of finding what's the median of this data? I have 27 zeros, 1 million, right? How would I go about finding this median? Well, one way is I can list it out, right? I can list out 27 zeros, and then the very last number will be a million. So I could do this situation here. I could literally start 0, 0, 0, 0, 0, 0, 0, 0, 27 times. Last number, a million, right? And then if I wanted to, I can, so 27 divided by 2, that's going to get me 13.5. So that means my median is going to be the 14th term. So 0, 0, 0, 0, so on and so on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's my median, right? And then I have a bunch of other zeros here, and then I get to the million. But either way, there's 27 zeros. So the 14th number in the order is going to be 0, right? I can do this visually as well. Guys. So if I take a look here, okay, now for this one, before I continue, these were also questions that are present in your IDS journal, okay? But I would much rather you answer these questions in your notes. I want you to answer these questions in your notes, okay? So I do not want these in your journal. So you can cut and paste them in your notes from your journal, or you can delete them completely from your journal and just make sure you handwrite them in your notes, okay? Another way that we can actually view this. What do you mean, David? The list? Yes, we can have decimal values as our data set. Sure. Yeah. So David's question was, is it possible that the list of numbers can be a decimal? Yeah, absolutely. There's nothing wrong. Decimals are real numbers as well, right? They're present in the real world. So yes, absolutely. So the class created a visualization on the right, a dot plot here, by placing the sticky notes on the corresponding values on the x-axis, okay? So I want you guys to consider these questions for your notes. What is the typical value of this data? What is the typical value of this data, right? These data here. And then I want you to use the formula we learned in class and calculate the mean or average value of this distribution. So remember, our formula for in class for mean, right, to find the mean that we learned was we add all of our data points together, and then we divide by the number of data points that we have. So summation of x over n, right? Summation of x over n here. This bit right here. Okay. So that's for question 2. Does the mean you calculated match your understanding of typical? Okay, why is the mean? So, and then we'll talk about these guys afterwards. So what do you guys think the typical value of this data is? I have 27 zeros, 1 sticky note with a million on it. What's the typical value of this data? Yes, thank you, Sarai. Yeah, thank you, Val. Yes, absolutely. Thank you, guys. Okay. Yes, thank you, Vicky. Thank you, Alexander. Thank you, Janelle. Thank you, Dario. Okay, thank you, David and Val and Sarai. Yes, the typical value we would think, right? Okay, there's 27 zeros. There's only 1 million. So our typical value is 0, right? So it's not wrong for us to consider that our typical value here might be 0. Okay, Okay, so let's go ahead and let's use our formula, our sum formula here, to calculate the mean. Okay, so let's see here. Calculating our mean. So our mean here is going to be, okay, I'm going to shorten this a little bit. We have 27 zeros, right? That's 0 plus 0 plus 0 plus 0, 27 times. So I can just shorten that and do 27 times 0, right? That's the same thing as adding 27 zeros together, plus our last amount here of 1 million, okay, divided by our total number of data, which is 28. Okay. Well, let's be real. 27 times 0 is 0, right? So really, we're doing 1 million divided by 28, which is going to give us, oops, going to give us 35,714.2857. Thank you, Maddie. Okay, there's our mean. That is the center, right? Or that's what the mean would say, right? If we were looking at the mean, that's what our typical value would be if I was looking at the mean there. Okay, so does that match what our understanding, does that match our typical, what our understanding of typical was here for this data set? No. Yeah. It yikes, right? Yikes. Look at that. We said that our typical value for the data is probably 0 because there's a lot of zeros there in 1 million. But if I use that 1 million and I find the mean comes out to 35,714. It's not even a number that's in our data. It's like we're not even close. There's no numbers even close to that number in our data. Okay. So why do you think the mean is not capturing our idea of typical here? Why do you think this does not reflect our idea of typical? I want you guys, massive outlier, absolutely. Absolutely. Massive outlier. That guy right there. Right? Huge outlier compared to the rest of our data. Guys, just a real world application here. A lot of times when we talk about income and like the average income in an area, this is something that happens very often when they talk about the average income in an area. Because if you really just think about the city of Long Beach, right? And the average income for the city of Long Beach. We have probably like 95% of the population of Long Beach is more on the low income to middle class income. Okay. Low income to middle class income. So we're talking like 40,000 a year to middle class, I think now is like maybe 120,000 a year. Okay, maximum like 150. So most of Long Beach, 95%, is in that category of low income to middle class. But then you have the other 5% that are way past middle class. We're talking like millions. We're talking like hundreds of millions, right? That they still live in Long Beach, but their houses are worth like 10 million. It's huge numbers we're talking about, right? Huge outliers compared to everyone else. Even a million, if most people are within like maximum 120,000 or 140,000, even a million income is a huge outlier, right? But when you find the average, when you find the mean of the income in Long Beach, those outliers shoot that average up. And so Long Beach ends up looking like it has a lot of population that's like making way more money than 95% of the population is even making. Okay, so this happens with income data a lot. That's why it's so important with income data that you talk about the median and not the mean because of that massive outlier. Okay, as Dario so beautifully put it. Okay, so what do you guys think the median is going to be for this? Right? What do you think the median is going to be? Well, we kind of already talked about that. Our median will probably be 0 because on the previous page, remember we did our little half thing? Okay, on the previous page, we did this 27 divided by 2, and that gave us, what did that give us? That gave us 13.5, right? 13.5, so jump that over to the next hole. So 14th place, 14th. So using this dot plot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here we go. 14. 14 is still at 0. So that means our median is going to be at 0 here. Okay. So now I have some IDS, some journal questions for you. So these are the first questions you're going to be answering in the journal for us. Okay. First questions you're going to be answering in our journal for us. And that is going to be here. Let me do this real quick. I want you guys to make sure you have the mean to look at. Okay, so that's going to be 35,714.2857. And our median, we had 0. Okay. The rest of this, I'm going to do this. Okay, so here are the questions for your IDS journal. We have why is there such a large difference between the mean and the median values, even though they are both measures of center? Okay, so I want you to think about everything that I just talked about. Okay, of how we're finding the mean versus how we're finding the median. Okay, why is there such a large difference between the mean and the median values? And is there a specific reason why the mean is larger than the median for this particular set? Is there a specific reason why the mean is larger than the median for this particular set? Okay, so I'm going to give you guys 2 minutes to answer this in your IDS journal. Yes, you are answering this in your IDS journal. So 2 minutes to do so, and then I'm going to call on a few people to share out. Okay, and go for it. Okay, let's bring it back to our PowerPoint here. Hopefully we're able to form some of your responses there. Maddie, can you share with us your thoughts for these answers or for these questions? Maddie? Oh, you're going to type. Okay. Can you just copy and paste what you wrote? Okay. I would also like to hear from Katie. I would also like to hear from Katie. Oh, Janelle, I can't speak. I'm so sorry, Janelle. Janelle, thank you so much for sharing. Okay, mean was greater than the median because the median is only asking for typical value. Meanwhile, the mean is asking for the value overall, right? So the mean typical takes into consideration everything, right? Whereas median, you're kind of just looking at your numbers in general. So Maddie, you said the massive outlier made the mean and the median values a large difference. Yes, that outlier absolutely made that big difference in our data. Absolutely. Okay, absolutely. Katie Hun, are you there? Katarina. Actually, that's not your name. Katie, 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 Katie. No, no. I think Katie's having some um issue stuff today going on. All right, that's okay. Thank you to Janelle and Madison for contributing here. I want to move on because I want to give you guys enough time to do what you need to do. Okay, so we're gonna do our 2.3a medians, dot plots, or histograms activity now. And I kid you not that I'm only giving you 5 minutes to complete this. You only get 5 minutes. You should already have it open. It's 2 questions, guys. It's literally 2 questions on it. You're going to look at the dot plot and the histogram and answer those 2 questions. And those 2 questions are exactly these. Okay, which plot makes it easier to find the median number of candies eaten, the dot plot or the histogram, and why? And then what is the median number of candies eaten? Okay, so these are your questions that are on the 2.3a document. I want you guys working on it for the next 5 minutes, starting now. I'm literally putting it on the clock and then we're bringing it back to class. 5 minutes. You're working on your 2.3a activity. Is one. So I'm seeing a consensus here that the dot plot is easier to read. I'm seeing that consensus. Okay. I'm also seeing a repetition that our median was 1 candy eaten. Okay. Median was 1 candy eaten. All right. Okay. I like it. I like it. Great job, guys. Well done. Okay. So now that we got that out of the way, I want you guys to do the 2.3b, where's the middle? But before you start 2.3b really quickly, I want to do a quick review on the skewing of data. Okay, if you guys remember, if you remember here, when we did our histograms lesson, one of our histograms lesson, we had right skewed, left skewed, okay, and symmetric data, right? We had right skewed, left skewed, and symmetric data here. And I want you to remember what each one looks like. Symmetric is more centered, right? Where you have a tail on each end. So symmetric is more centered where you really have a tail on each end and the peak happens pretty much toward the middle. Okay, left and right skew, they refer to the tails. So if on a left skewed data set, your tail is to the left. So your tail there is on the left side. On the right skewed, your tail is to the right. Okay. So it's all about the tail of your data that tells you which side it's skewed to. The reason why I bring that up is because in 2.3b, you are going to be asked to identify if it's a left skewed, symmetric, or right skewed graph. And then you're going to be asked to find the median and compare it with the mean, which they give you. Okay. So there are 6 graphs on there. And one of them, the first one has been done for you as an example. So pay attention, read the first one, understand what they're talking about, okay? You're gonna be asked to compare the mean, the median. So it's gonna ask you like, which one is larger, the mean, the median, or is the mean approximately equal to the median, right? So you wanna pay attention to that as well. So 6 graphs, one's already done for you. So you really only have 5 graphs to do. Each graph shouldn't really take you longer than a minute to do. So you're getting 5 minutes to do this activity as well. Okay, 5 minutes to do this activity as well. When you are done with it, I want you to raise your hand. Okay, for this one, when you are done with it, I want you guys to raise your hand. Okay, starting 5 minutes, starting now. Go for it. All right, well done. Thank you. Thank you guys. You guys are doing great. We still got half our class not with us though. Please raise your hand if you are back with us on the PowerPoint. Raise your hand and wave it like you just don't care. Let's see here. Thank you guys. Thank you. Thank you. Still waiting to see a raised hand from Dario, Gabby, George, Katie, Kenya, Matthew, Trinity, and Tyrese. All right. Thank you so much, guys. Thank you. Well done. So based on your findings, based on what you just did, okay, I want you guys to look at, I want you guys to look at the three types of graphs that you were looking at, right? Left skewed, symmetric, and right skewed. And looking at what you found for those graphs, I want you to take a look and answer these questions. Why? Okay, what did you notice about the relationship between the mean and the median values for our symmetric data? Okay, for our symmetric data, what did you notice for the mean and the median values for the symmetric data? What did you notice about the relationship between mean and median for the left skewed data? What did you notice about the relationship between the mean and the median for the right skewed data? Right? So what did you notice about the relationships? I want to give you guys, actually, gosh, we're running out of time. I want to make sure we cover this though. Can anyone volunteer? Can anyone volunteer what they noticed for the symmetric data? Let's see if we can get some volunteers here to
I could volunteer.
Thank you, David. Go for it.
Yeah. So what I noticed about between the mean and median for symmetric is that they weren't exactly similar. It's just they were very close enough to where it looks like they can be about the same.
About the same. So for me, for the symmetric data, our mean was approximately the same as the median. Almost,
yes.
not perfect, but they're very close together.
Mm-hmm.
Okay, very good. Thank you so much. Can I have someone else contribute? What did you guys notice about the data for the left skewed data or the left skewed distributions? What did you notice about the mean and the median for the left skewed, these guys here? Okay, any takers? Let's get some volunteers here, guys. Please. Trying to make sure we get to leave at 12:04. Trying to make sure we get to leave at 12:04. Okay. So Janelle says that for left skewed data, she noticed that the median was higher than the mean. So our median ended up being higher than our mean would end up being, right? Our mean would probably be here, median would end up here. So for left skewed data here, we had our median was greater than our mean, okay? So then does that mean for the right skewed data, for our right skewed data, it was the reverse? Can anyone confirm? Is that what you noticed? For right skewed, this guy, was our mean greater than our median? Yes, okay. So for right skewed, we had our mean greater than our median here, okay? So this is what we mean. If you guys remember at the beginning of class, we said, it's better, it's preferred to use our median, right? It's preferred to use the median when we have skewed data. When we have skewed data, it's better to use our median because it's different than our mean, right? So when we have skewed data or our skewed distribution, I should say, a skewed distribution, we want to use our median because it's very different than our mean. A skewed distribution, use the median. And of course, we also talked about the fact that also we want to use our median with outliers present, right? We want to make sure we're using our median when our outliers are present. And that's mainly because of this discrepancy here for the skewed data, right? When our data is symmetric, we end up having the same amount of data here and here. And so our median and our mean end up being around the same. But when we have skewed data, a lot of our data over here on the left skewed is over here. A lot of our data is over here on the right skewed is over here, and we have very little on the tails. And that's where we get that discrepancy in our median and our mean, okay? So I'm sorry that that was a bit rushed, guys. We're not gonna have that discussion here. I just wanna bring us over here to our homework, okay? I wanna bring us over here to our homework. Can I erase this? I hope you guys are cool with me erasing this. Anyone still need this? Okay, so our homework, ladies and gentlemen, is you're gonna be doing the 2.3C, understanding personality colors data. And what you're gonna do is you're simply gonna be finding the mean and the medians for our values, for our scores, for all the 4 different colors of personality that we had, the blue, green, orange, and gold. So you're gonna be finding the means and the medians using RStudio, and then comparing them and answering a few questions. It's the reason why we took the time to make sure that our data was downloaded, okay? Other than that, guys, if you're good with our lesson today and the idea of median being another measure of center and when we can use median over mean, have a wonderful, wonderful day. I will see you all on Thursday. Destiny Hun, if you can stick back for a quick second so we can take care of that one issue, and then you can head out as well. All right. Bye, guys. Take care. Have a great one. Okay. Be safe. I will see you on, I will see you guys on Thursday.
All right, Miss K, have a good one.
Bye, David. You too, hun. See you guys. Take care. Bye, Dario. Destiny, can you privately send me your username and login, please? Bye, Samai. Okay. Destiny, hun, are you there?
Yeah.
Okay. Can you privately send me your username and login?
Okay.
That way, I'm not going to mess it up. And I'll upload one of my files and you'll be good to go. So I'm just going to upload it. You'll need to import it, okay?
Okay.
I was trying to remember who my second one was because I know Eric has the same issue during my third period. His does
Yeah,
not.
I know it did this the last time with the other data set.
Yeah, so whenever we do this, you just got to remind me, and I'm happy to do it. It's fine for me to do it. You just got to remind me, hon. And it's,
Okay.
yeah, it's just a matter of like, I just got too much to remember. So, do you have that username? Are you looking
Damn.
up?
I have the username, but I can't remember the password.
Oh, you
It's saved on my thing.
Okay. Girl, you say something so I can like pull it up. Oh wait, hold up. Oh shoot, hold on.